We are still in your foldable, working our way down the parallelogram side. We're about to wrap it up with this. So you need to be in your square flap, and it's just a one-sided thing. And the definition of a square is kind of cool because there's nothing really new to add. It's a parallelogram. We've seen that all the way through this. But it's both a rectangle and a rhombus. You probably already knew that. So what does that mean? Well, we need to make sure that we have all the properties of rectangle covered in a square. So draw yourself a little arrow pointing back up to those rectangle properties. And at the same time, it's got the properties of a rhombus all combined. So it's like a very romantic love story since Valentine's is coming up. It's a rectangle and a rhombus. They got together, fell in love, had a child, named it a square. So let's look at what it inherited. This square inherited some things from its rectangle father. And the first thing is those right angles. It's got the 4 right angles just like any rectangle does. What else does a rectangle have? When we draw the diagonals in, remember the diagonals are the same length across. So, whoa, got a little out of line there. So these are going to be tick marked to be exactly the same length because of its rectangle properties. And then let's add in the rhombus stuff. So now a rhombus, those diagonals, not only do they have the same length, but in a rhombus they hit at a right angle as well. They're perpendicular, remember that? And, oh, I'm getting ahead of myself, it's a rhombus, so we better put in these 4 sides are the same, that's a given. And then those diagonals, back to the diagonals, they bisect the angles. So those 90-degree angles from the rectangle just got chopped in half, each one being 45 degrees all the way around. So we'll just mark a couple of them. All right, now I'm going to show you a quick video just so you know what a square is good for, and then we'll move on.
Stop! No one crosses this bridge by me, unless they can answer my questions 3.
All right, Bridgekeeper. What are the questions?
What is this?
A square.
How many sides does a square have?
1, 2, 3, 4. 4 sides.
What is a square good for?
My building blocks. Look, they're square.
All right. You may pass. Stop. No one crosses this bridge by me unless they can answer my questions 3.
Okay.
What is this?
A square.
How many sides does a square have?
4 equal sides.
What is a square good for?
Look, a square makes a nice picture frame.
You may pass. Stop! No one crosses this bridge by me unless they can answer my questions 3. What is this? Oh, a square! How many sides does a square have? 4. What is a square good for?
Good for? These things are great. I eat 3 square meals every day.
Love it. All right, so you've got 4 questions to answer from me, so you can pass. Here we go. In this square, D to E is 10. Let's jot that down in our picture. So D to E is 10, and we're going to find the length of AC, this diagonal AC, and then we'll do another problem where we get to find BC, one of the sides. Well, let's go ahead with the 10. Remember, this is a rectangle just as a square, so we've got 10 on each of these pieces, and the other diagonal is exactly the 10. So what does that make? AC all the way. AC is going to be doubling the 10. AC is 20. Hopefully you can see that. Now the tougher question is probably the BC side. So how long is BC right here? Let's put an X on that. For this one, we're going to have to remember that we've got a right angle right here. This might be the easier way to do it. And I'm looking at that because I want to notice that I've got a right triangle. Let me highlight the right triangle for us. Looking at this right triangle right here. And anytime I have a right triangle and I'm looking for a side of it, I'm going to be using the Pythagorean Theorem with these. So remember, the Pythagorean theorem is going to say a squared plus b squared. Let that equal c squared. Where's our hypotenuse in that right triangle? Right across from the right angle. So we're going to use x as the hypotenuse number. That's our c. So sticking x in there, what are our a and b numbers? Those are the two sides 10 and 10. Okay, so let's set this up as 10 squared plus another 10 squared equaling x squared. And let's do the solving. 10 squared makes 100. 10 squared still makes 100. We got two of them. Combining those gives me 200. And let's bring down the x squared. So how do I get rid of the square? You know, square root, both sides. So the square root of 200 is my x value. What is that with a calculator? We're going to do some rounding here. Let's see, grab a calculator. Square root of 200. I'm getting about 14.1 if we're going to round it to the tenths. So that's the BC length, 14.1. Of course, that's the same all the way around my square. And we're done. So Pythagorean theorem, just like we saw in rhombus. Let's try this next one. No picture, it's up to us. So let's go ahead and sketch a picture of a square. And I'm going to start right here with S, work my way around, Q, U, R. The perimeter of our square is 60. The perimeter is all the way around, 60 total. Well, let's take that 60, let's just chop it up. 60 and divide it by 4. Why am I dividing by 4? You know, all these sides are the same. I'm just going to figure out what one of them is. So 60 divided by 4 gives me 15 on each side. Let's put that in our picture. Our job is to find the length of a diagonal. I'm going to just draw one in. You can draw either one, but there's a diagonal. Call it x. Let's figure out the length of that diagonal. I'm saying Pythagorean theorem again. We got right angles. This time in a big right triangle. Let's highlight it just to see it a little better. Big right triangle right here. Here we go. Alrighty, you know the routine. A squared plus b squared equals c squared. What's our c this time? Oh, across from our right angle, it's our x again. So x squared there, and then our 15s go in for the other two sides. 15 squared plus 15 squared is x squared. Crank it out. 15 squared is 225. No matter how many times you ask it, 225. So altogether we've got 450 for our x squared number. We don't want x squared, we want to know x. So grab a calculator and take the square root of 450. And decimal on that, 21.2 is about the value of x. So that's about how long our diagonal length is, 21.2. Love it. All right. Next question. Another picture for us to draw. Let's sketch this out. So we get another square. Name this guy M, N, O, P. Work your way around. And what is the measure of angle M, N, P? M, N, P. Oh, it looks like I've got to draw in a diagonal here to get that angle. So let's sketch in the diagonal. Now, angle M, N, P is right here. We want to know this angle measure. This is not too bad. If you remember just from our notes just a minute ago when we did the definition, how big is this angle? It's a right angle since it's a square. And the diagonal bisects it because it's a rhombus. So each of these guys is 45 like we saw in our definition sheet. 45 here and 45 here. So 45 is our answer, 45 degrees. That wasn't bad. How about this one? They drew it for us. That's nice. Let's look at angle AEB. Angle AEB. Find it right here. 6x. Find the value of x. Well, what else do we know about angle AEB? Remember? Just like any rhombus. 90 degrees. And a square is a rhombus. So 6x right there is a 90-degree angle. They're all right angles there. So we just do this straightforward. 6x is equal to a 90-degree angle. Divide by 6. X is 15. Easy as that. Alrighty. Hey, your turn. Do your try these questions. Keep the video rolling though. I'm going to play a little song from Sesame Street. Nothing like a little Sesame Street to wrap it up.
I'm a square, look, I'll show ya. I got the four sides on me. All my sides are the same size, like a good-looking square should be. Well, I So hip to be a square. To be a square.